All right, welcome everyone. Today we're going to talk about object-oriented programming and the concept of inheritance and polymorphism. Today we're also going to cover the fifth pillar that people may ask for, which is composition. Let's go and start talking about inheritance and polymorphism. So first we're going to talk about when and why to use inheritance, child and parent relationships, the super method, instance versus, oh, we already talked about instance versus class methods. Not sure why that's still there. Multiple inheritance, and then composition versus inheritance. Again, all of these concepts you'll be tested on during assessment one at the end of this week, which is coming up. It's almost Friday. All right. Any questions over what we'll be covering today or how you'll be assessed? Perfect. So, why use inheritance? Every single time we go into creating a blueprint for some sort of behavior, we may want to expand that blueprint to have new features, to have new methods, new properties. But whenever we go into expanding that method, we don't necessarily want to start all over the place, right? Maybe we want to create different versions of a singular class. So here, what I have here as an example, we can see there's the class of phone, which we have our very old phone on the left-hand side. This phone was probably the original, right? Back in the good old days. And from there, eventually we came up with cell phones. Well, cell phones, although still have the ability to make calls to one another, they also have the ability to browse the internet or do other things such as take pictures. But when the phone was created, we didn't start the entire basis of how phones work whenever we went into creating cell phones. Instead, we took the blueprint of a phone and we created a blueprint for a handheld phone. We created a blueprint for a foldable phone, and then we created a blueprint for a touch screen phone. All of them, in the end, are still just phones, right? They're just cell phones rather than a phone. So on the right-hand side, we may see something that goes along the lines of class of cell phone, which inherits from the phone class. Something like this. All right, let's go and continue moving forward here. Now, why use polymorphism? At the same time that we are creating those new versions of a phone, we may have to have the same exact method, but may need to make it work in a different way. So an example of polymorphism are things that accomplish the same goal, but maybe accomplish the same behavior through some sort of different inner workings. So here's an example. We have Google Meets on the right-hand side. We have Zoom and Skype, all three of which allow us to have some sort of virtual meeting where we can have camera, audio, we can create recordings, we can have transcripts. I don't even know if Skype is still a thing. I'm sure it is, but we have all three of these platforms to be able to make those kinds of phone calls, right? But they all work a little bit different. I'm not going to go into the inner workings of how they all work, but they all accomplish one goal in a different manner. So one goal being accomplished, or let's just say one behavior is accomplished. All right. Does anyone have any questions about inheritance or polymorphism? Perfect. If no one has any questions, then let's start seeing some code and start talking about inheritance before we even move into polymorphism. All right. Well, what is inheritance? Before, we talked about the concept of having a dog. Now, the dog class might represent all types of dogs. And we may say, hey, well, we know all dogs will have a certain number of legs, but they will have legs available to them. We know that all dogs will be able to bark or have a sound available to them, which in this case, let's say that it's woof, or let's just typecast it for now. All right, we have an integer. We have a string. What else can dogs do? Or what other attributes can all dogs have?
Breed.
Okay, they may have a breed. I'm actually going to skip the breed part here. That's a good one, but I'm going to skip it. Let's go
Color.
back to say again.
Color.
Yeah, they may have something like color. Awesome. And we'll put this as a string as well. Now, what about behaviors? What kind of behaviors can dogs have?
Speak.
Okay, so we know that they can speak,
Chase tail.
they can chase tail. We know they
Sit.
can eat, they can sit, and so on, right? Well, we can leave our dog class just like this, where it has some sort of template as to what a dog is to entail. Now, when we go into creating a dog, we can create many dogs. And we can just do something like specify the breed. Like somebody brought up, breed might be an attribute that we can go ahead and talk about. But what if instead of specifying the breed, we want to take it a step further and we want to create something like, hey, this is going to be a German Shepherd. And instead of that, we can even say, hey, not only do we have a German Shepherd, but we may also have a Bulldog. Um, Maybe we even have something like a Chihuahua. All of which have their own attributes, right? So we know, I have a German Shepherd. So I know for a fact that one of the best behaviors of a German Shepherd is shedding all the time, all the time, all year, just fur everywhere, right? So we know that's a behavior. What other behaviors can German Shepherds have that may be unique?
Defend. Protect.
Yeah, maybe we can train them to be protection, right? They can also eat. They can also sit. They may also have, um, not only do they have legs, sound, and color, maybe we can specify something like, hey, shots, right? Do they have their shots? And that may be a dictionary available to them. And as we move into Bulldog to Chihuahua, they may all have their own small attributes that are unique to each one of those animals, right? So instead of creating the class all over again from the scratch and saying, oh, well, I know this should also have legs, it should also have sound, also have color, it should also be able to chase its tail, it should be able to eat. Oh, I already have eat and sit there. And it should be able to speak. Instead of rewriting everything by scratch and putting it all within my dog class, instead of what I can do is I can identify, well, hey, all of these dogs will have legs, sound, and color available to them. So if I know that, instead of writing it in every single one of these dogs, what I can do is I can specify, hey, this is a German Shepherd, which is a class of dog, or is a dog. A bulldog, again, is a dog. And lastly, for a Chihuahua, we can say is a dog. And in doing so, we no longer have to declare things that are already shared, like color, sound, legs, the ability to chase one tail, the ability to speak. We don't have to specify they eat, and we don't have to specify that they sit. All of these other attributes that we have already created will be moved into the dog class, or excuse me, into the German Shepherd class throughout inheritance. So this is more of a visual representation of what we're about to be doing. Does anyone have any questions over the visual representation before we start diving into code? If no one has any questions, then let's go ahead and create one. We have a class of dog, where this class of dog takes in an init method, may take in a number of legs, may take in a sound, a color, all right. We know that self.legs would be equal to legs. Sound would be equal to sound. And we know that the color would be equal to color. Up to this point, we're just initializing. We created an initializer that can initialize the instance of a dog. Now let's go into some instance methods. Now, in these instance methods, we can have speak, which again, the very first argument will be self. And then we'll return a string passing the sound of a dog. All right, we can have something like chase tail. Again, passing self. I can return a string saying self dot. Oh, well, this doesn't have a name. So we can say dog is now sitting. And then we can have,
Is now chasing tail, maybe?
oh, is now chasing its tail. Thank you for that.
While caught tail equals false return.
Yeah, we could do something like that. You guys want to do a whole while loop? Let's do it. Why not? Let's do caught tail be equal to false. While, or let's do that to true. Not caught tail. Let's do print. Dog is now chasing tail. Let's get fancy with it. Why not? Let's import time. Let's do counter be equal to 0 and say if counter is less than, well, let's say greater than 5, then cocktail is equal to true. Do time dot sleep. Send it for 1 second. And then at the end of it, we'll say that it returns dog has finally caught its tail.
You have to append to counter before you start that.
Thank you. Counter plus or equals 1. All right, there you go. So now we have a whole while loop iterated in there with a counter and some sort of timer. Now let's go into the dog being able to eat, right? Let's say, hey, a dog should be able to eat. Again, this is going to take in self, and we can specify, hey, this is going to be a string method that will return dog is currently eating. And then finally, we can specify a sit method, which takes in self and returns dog is now sitting. All right, so many methods have been created here. And we can actually create an instance of the dog class. Let's do so. And say my dog be equal to dog. We know that it takes in a number of legs. It takes in a sound. Let's go with wolf. And it takes in a color, which let's go with brown. Now, if I access my dog, I can say, hey, I wanted to chase his tail. What does that look like? I can also want it to eat. I may ask it to sit as well. So there's all three of our behaviors. I can even ask it to speak. All right, and let's go ahead and run this code here. So dog is now chasing its tail. He's still chasing his tail. I think I did it for 5 seconds. All right, dog has finally caught its tail. The dog is currently eating. Dog is now sitting. And then finally for speak, we get woof. So all of the behaviors that I wanted to belong to a dog now exist. Awesome. All of this should be pretty much of a review. But just in case, does anyone have any questions over what we've completed up to this point? All right, there are no questions. So now let's start writing some code in regarding to our German Shepherd dog, right? And let's actually do this in a separate file. All right, so here we have our dog class on the right-hand side. Now I'm simply going to create a German Shepherd class on the left-hand side. Let's try to do it this way and concentrate about the initializer first. Let's go ahead and do GSD and create the initializer. On the initializer, I may do something like self. Again, I want to make sure I have legs, so we're going to have an integer. I also want to do something that says, hey, I also have sound. So we know this is going to be a string. And maybe I have something that has a color, which is also going to be a string. As of now, the initializer looks almost exactly the same. But now this isn't just any common dog. This is a German Shepherd, so I may want to add something like, hey, I also want this to have a nickname, which is of a string type. And I may also want this to have something like, it's another descriptive thing. Maybe I want
Gender.
something like owner, which may be a dictionary. Sorry, could you say that again?
I said gender.
Yeah, why not? Let's go ahead and do something like gender, which may also be a string. All right. So there's our German Shepherd dog. Now, when we go to initialize it, we may want to do something like, hey, I have self.legs be equal to legs. I have something like self.sound be equal to sound. Self.color be equal to color. The name, oh, be equal to name. Owner, that may be equal to the owner that's being passed. And then self.gender, that is equal to the gender. All right. Now, what's the issue that we just ran into? Not necessarily an issue, but what concept of coding or the entire purpose of object-oriented programming is it that I'm violating right now?
Don't repeat yourself.
Don't repeat myself, right? We want to think of dry syrup. So dry means don't repeat yourself, and then syrup meaning single responsibility principle. So dry syrup. Well, I am definitely repeating myself because I am passing information that I've already written. And if I were to go and write all of these methods, well, I would just simply write these methods all over again. And I could even go to the point where I'm copying and pasting code. And now my code may end up looking like something like this. But this isn't necessarily the behavior that I'm aiming for. I'm repeating myself over and over again. And not only do I have to create a German Shepherd, later on I have to create a Chihuahua, and later on I have to create a Bulldog. And as more and more dogs are created into my system or into my ability to manage dogs or represent them in object-oriented programming, I'm repeating myself again and again and again. Well, that's not necessarily something that I want. So this is where inheritance comes in. I'm going to go ahead and from dog, I'm going to import the dog class. Now, when I go and import this dog class, or actually, let me show us an example first of how everything works so far. I'm going to go ahead and create my dog, make this equal to a GSD, which takes in sound. Let's go with wolf, since it's a little bit louder. Color, maybe brown. Let's say the name here is Apollo. The dictionary for the owner, which may be name. And then maybe something like phone. All right. And then finally, I can move into the gender, which in this case, it's male. Now let's create our dog. By going to my dog.chasetail, and I print this onto the terminal. Oh, hello.
You're typing Python dog.py instead of Python GSD.
Yep. Thank you. So we see the dog is now chasing its tail. Going through. The method is eventually successful, and again, dog has finally caught its tail. So the behavior that we wanted is working, right? Nothing has changed. But now I want to actually utilize inheritance. And before I go into the syntax of inheritance, I saw a hand go up, so let me go ahead and address that question. It's been a while. Go ahead, Carlos.
Yeah, sorry. So it's kind of, I guess, kind of out of the scope. But whenever you do, I guess, a parameter for gender, since really it can, I mean, I might, well, whatever. It can be either male or female. Like that's really your options, right?
Right.
So is there a way to specify that in the beginning? whenever you in your parameter say like these are your deep like these are your only two options. So if you put anything else, or does that have to go into the setter method?
There is a way to specify specific options, but if you do specific options, you would have to make those variables prior to, and then reference those variables within the type casting here. So you would have to create your own type. That type being created would then have to be referenced to within your initializer. I'm not going to dive into how to do that, but it is feasible,
Okay, thank you.
of course. All right, now let's go ahead and continue here. I was able to create my dog, but I have a lot of copied and pasted code. Well, let's fix that. I'm going to import my dog. And let's make sure that that import was successful. Let's just go ahead and print dog. All right. And I see that import was actually not successful. So it says from file to GSD from .dog attempted relative import from no parent package. Okay, let's go ahead and make our init file. Yep, there you go. So now we have init.py. And now let's run that again. From no parent package. Easy peasy. Let's change that up then. There you go. So now we were able to import our dog class, and we can see that import statement actually printing down below. It tells me inside of the dog file, there is a class named dog. Go ahead, Nick.
If you get rid of the init file, will it not allow you to import like that?
I believe it will still work. Let me try it out. Yeah, so it still works. All right. I'll go into the init file and we'll cover the init file later on as we start working within bigger modules. I apologize, everyone. All right. So now that we have this print statement, we know that dog has been imported into our file correctly. How do I do the portion of inheritance or of adopting all of this behavior that I've already coded once? Here in GSD, we're going to specify that this is of a class of dog. And in doing so, properties and behaviors both at the class and instance levels are now present within the GSD class through inheritance. Well, what does that mean as far as code? Well, that means that I no longer need to specify that we have legs. I no longer need to specify that I have sound. And I don't need to specify that I have a color. I already have a speak method. And I have all of the following methods as well. I can comment all of them out. But now we have a problem within our initializer here. Legs, sound, and color are not being referenced to. Well, although I'm inheriting the class of dog, the class of dog still needs to be initialized in order to create my GSD. And I do so as such. I say dog dot init, and I pass in the following arguments, such as, hey, the legs that I have currently are going to be legs. I'm going to pass in the sound, and I'm going to pass in the color. So there's a little bit of a tunneling here. Whenever I go to create my instance, it will go to the dog first, or excuse me, Let me scroll down here. Whenever I go to create my instance, all of the arguments that I want to create are going to be passed into my GSD class. My GSD class will grab what it needs, such as gender, the contact information for the owner, and the name. And then the amount of legs, wolf and brown, or so sound and color, are going to get passed up to the dog class to initialize the remainder of the dog. All right, so now let's take a look at how this is working. And then we'll open it up for questions. Looks like we still need to pass in self there. I apologize. Oh, should probably print some sort of behavior. We get the dog is chasing the tail, and we were able to create an instance of a German Shepherd dog, which is a dog. Notice that I was still able to call the method of chase tail, even though the method chase tail has been commented out. That's because it's referencing to the chase tail that exists within the dog class. All right, let's open it up for questions. Go ahead, Michael.
The order that you enter in things like name, owner, and gender, can those be rearranged or basically not the same as the init method in the dog class? So like the dog.init in your GST class, let's say they were a different order. In your GST class at the bottom, you put in all of that information. That order just has to mimic what's in the dog.init class or init file method.
It doesn't have to be in the same order when you're calling it within the initializer here on line 8, but it does have to be in the same order, or it has to be deconstructed through a dictionary on line 11. Right? Because at that point we're passing the correct parameters into the dot class. Does that answer your question, Michael?
But it doesn't matter the order in the actual dog.py file. Is
Yes,
that correct?
it does
Okay.
matter. Yes, it does.
Okay.
All right, Justin.
I think I know the answer to this, but you wouldn't have to reset up your getters and setters, would you? It would come with the inheritance.
We're going to talk about that here in polymorphism during the second portion of our class. All right. Any other questions?
I had one. So in the reading for the Python crash course, they were using super init versus calling the actual class dog on the initiation part.
That's a great question. So let's go ahead and start talking about super. And actually, before I open it up the whole chapter for super, let me go ahead and address any other questions that may be up to this point. Does anyone else have any questions before we move into super?
Can you go back down to where you made a new variable for GSD? Yeah, my dog. Could you explain that for again, please?
The number 4?
Yeah.
That's just
Oh, it's just a variable. Yeah, okay.
all right.
Right.
All right. If there aren't any other questions, then let's go ahead and start diving into super. So what we're doing here is we are calling the dog class, and we're specifying, hey, the dog class is what's being initialized, and it's being initialized with the following arguments. And we're even calling in self. Now, the super method doesn't do too much for us, right? It is useful. We can say super dot init. And when you utilize super, I may be wrong, so let me try this out first before I even open up my mouth. It requires a super object, but received. Oh, hello. All right, so that worked. Perfect. So we call super. And what super is going to do is by default, it's going to grab the class, initialize it, and that's why we don't need to call self. It's saying, hey, this is a class that is inheriting something. We know that what we're inheriting is dog. We don't need to have self being passed in because of the super method, and we can just pass in legs, sound, and color directly into dog. It's just a shortcut for syntax rather than explicitly explaining what's being initialized and what parameters are being passed into what class. We're implicitly passing parameters into the correct class. Does that answer your question, Dan?
It does. So basically, the benefit is just saving a couple keystrokes. Really doesn't have any different functionality then.
It doesn't really change anything under the hood. Correct.
Could you explain it one more time?
Yeah, absolutely. So again, whenever we go in and create our dog class originally, we created it by saying, hey, we have a dog that we are going to initialize, and we needed to still pass in self, saying this is going to be an initialization of dog itself, right? When I created my GSD, I passed the instance of GSD into the dog class, letting it know, hey, what I'm creating now is a dog. By passing in the super method, I'm saying, hey, check if this is inheriting anything. We are inheriting. What we're inheriting is the dog class. And because I am inheriting the dog class, here in these parentheses, I'm taking care of the self portion. So I no longer need to pass in self. Right? I'm creating an instance of both the German Shepherd dog and the dog class with the correct parameters. Rather than explicitly, meaning defining key by key, what's being created, I am implicitly creating an object.
So, if I'm not mistaken, in theory, you could like assign, put a variable. I'm not sure if you're able to do this, but could you put a class into a variable and make it like change depending on whatever, and then have like the super anonymize that, I guess, in the case that you wanted to do that, to do something like that?
So what you're talking about is composition, and
Okay.
super is more related to inheritance than composition. So it would contradict that concept.
Okay.
All right. Any other questions? If no one has any questions, then let's go ahead and build a simple class ourselves. Let me go ahead and make a separate directory here. Let's call this one people. And in here, I'm gonna have person py, and I'm gonna have a, let's do a father.py. How could I define a person as an object? I'm gonna go ahead and make an initializer here, passing self, and then let's open it up to the class. Carlos, how would you define a person?
You can do name, gender,
Right?
height.
Height, let's do weight, why not?
Branch of service.
If there is one,
Veteran.
not every,
Veteran.
not
True
every
or false?
person, not every person is a veteran, but why not?
Civilians a branch too.
Look, it could just be veteran, true, false, or something.
All right, let's do veteran.
And then if we had a subclass that was a veteran, then it could have the branch.
All right. So now we have a name that could be equal to a name. We have a height that could be equal to a height. We have a weight that could be equal to a weight. And yes, I'm aware I am skipping this portion. And we have a veteran that is equal to a veteran. All right. So there is our initialization for a person. What kind of behaviors can we have for a person, Marshall?
Behaviors like eating and hobbies. I don't know.
All right, let's say sleep. All right. We may be able to eat. Drink. Sleep, eat, drink, and let's stop it there.
Clean? Oh,
All right. So now let's go ahead and pass in self. And let's go ahead and return this person is sleeping. We're eating. We can say, hey, this person is eating.
Could you pass in like the person's name so it's flexible when you inherit it to other classes or other pages?
Yeah. Let's go ahead and do self.name. All right. And then finally return self.name. And maybe here we pass in liquid means drinking liquid. All right, so we've been able to create a person class here. Now, let's go ahead and from the person class, let's make a father. All right, let's go into code, father.py. Maybe a father is the wrong example. Why not? Let's just do veteran. One, two. All right. So now, how could I create a veteran? How would we describe a veteran when it comes to properties? And let me go ahead and pass that into Jay.
Yeah, for veterans, we could have an init for branch, maybe awards,
Awards.
MOS. Yeah,
Okay. What else?
branch,
All right, branch
time of service.
and time in what? Let's do TIS. All right.
Number of article routines.
So NJPs. Why not?
Or false, yeah.
All right. Awesome. So now we can go ahead and specify. Um, well, I think they would still also have a name, right? They would still have a height, a weight, hopefully. And I guess we don't really need to specify if they are veterans at this point. Now let's go into assigning them. Before I go into the whole assignment process of doing self.name, self.height, and so on, how could I apply inheritance into these two classes? Andy?
Well, we're gonna have to import the class from the person. So from person, import person. And then in the under the def, or actually no. So we're gonna have to do veteran, class veteran, and in the what do you call them? Open and closing parentheses, we're gonna put person, And then under init, we're gonna do a super. Yep, dot. Was it init? Yeah. And then inside, we're going to plug in the ones that are supposed to be in the original one. Yeah. I guess we're not gonna include, I don't know. Yeah, okay. Oh, okay. Well, you answered my question there. Well,
Perfect. And now for whatever is unique, we can say, hey, the awards are equal to awards. We can say that the branch is equal to a branch. We can say TIS is equal to TIS. And then finally, NJPs is equal to NJPs. Is it called NJPs in the army? I apologize, everyone. I'm not sure if that's the same terminology in the different branches.
Non-judicial punishments?
Yes.
We
Thanks,
don't
Ross.
really use that, but yeah, I can understand it.
All right. Awesome. Michael?
What would happen if you didn't put like true in the super? So like you did the super, but there was no value for veteran basically.
Well, that would still throw an error saying that there's a key that or a parameter was expected but was missing parameter of veteran. So if we go to take a look here, and let me go ahead and pass it down. Let's actually create our veteran really quick. Be equal to
would defaulting it to the true solve that?
yes. Height. Let's go ahead and do 5'7". Weight. Let's do. Oh, don't need to put that in parentheses. 207 awards. Oof. Not gonna go into this.
Cab.
Not enough. Let's go into that. Branch. Do some C. Time and service 8. NJPs. Too many actually. And when we go into creating our veteran, let's say that our veteran is sleeping. So now we can go ahead and do Python veteran. And you can see here that we see super init, name, weight, and height being passed in. It tells me one positional argument is missing, and that positional argument is veteran. So if I were to pass it in now, we know this is a veteran, so we're just going to default it to say true. Hey, this is a veteran. Now it's able to pass it in, initialize the class of person, and give me access to the method of sleep. Does that answer your question, Michael?
It does, thank you.
Of course. All right. Does anyone have any questions regarding inheritance?
I have one.
Let's hear it.
If you use the spread operator, will it only append the ones that you didn't initialize below it?
If I use the spread operator.
Yeah, on the veteran, you go up and use the spread inside the init, will it only pass in the ones that you didn't list below?
Give me a second.
Or will it still take all of them?
I think you can utilize a spread operator, but if you utilize a spread operator, you'll have to do it like this. Name, height, and weight. And finally, I think this is where the issue would come in. You would have to say veteran.
For a default, isn't it equals? Maybe?
No, because now I'm trying to specify a dictionary. This might be a really bad use case for it. Because if I were doing it this way, it may work. And then I could pass. Oh, then I could pass it true. There you go. And not throw an error as well. Argument cannot appear after keywords. There you go. Must be mapping, not a set. Yeah. So star. There you go. So you could do it this way with 1 star and then have the veteran equals true afterwards. I don't want to open up the whole black hole as to what's the difference between 1 star and 2 stars and how the spread operator works. Because that's going to take me a whole other half hour to explain. Uh, so I would recommend looking into this on your own as to destructuring an object with just 1 star versus 2 stars. But this is a different syntax to be able to do that. Does that answer your question, Cody?
Yeah, I was looking into it and they use 2 stars and keywords, keyword arguments, but that would just pass in everything that you listed on your above init. But I was wondering though, if you did the keyword arguments, is it only pass the ones that you didn't list below? So like it wouldn't pass awards and TIS and NJP, it would only pass the ones not that's I can look into it. I don't know, hold it up.
So when you utilize something like keyword arguments or quargs, what it's doing is it's going into the super, which in this case is a person, and it's looking at all the arguments that were passed inside of the initializer and matching them to the
Okay.
arguments
So
that
it
were passed into the person initializer.
so it would only grab those four.
Exactly.
Okay. Okay.
All right, Andy.
Yeah, since this is a initializing, why would we even use destructuring? Because there's nothing in the memory yet.
There's nothing in the memory as of now, right? But when we go into creating an instance of veteran, like we do in line 14, now we're actually passing key value pairs. So we're passing a value into name, we're passing a value into height, and that's where the destructuring comes into working in line 7. Because when we go into initializing, yes, it's empty as far as I'm writing it in line 6. But when this call or this function is being executed, it's not empty. It's actually having parameters that are being passed in to create key value pairs. Does that answer your question, Andy? Go with the no.
I guess. I guess I'm not even understanding if we're doing super init, why the def init still have the same properties. I thought we were supposed to like take out name, height, and weight because they are coming from the super.
Got it. So even though we are still utilizing inheritance and passing it in through the super, in both of these examples, or excuse me, if I were to create a person down here, the person would need a name, height, and a weight. And then it would also need a veteran status of true. Right? That's what we said we were going to pass into the person. So in order to create a person, I know I'm always going to need these 4 parameters. Now, when I go to initialize or when I go to do inheritance here, I'm not just creating an instance of a veteran, right? The person needs to be initialized as well. So I need to be able to pass in the proper arguments to the person down below in order to create a new instance. So just like I did here, I provided name, height, weight, and a veteran status. All of that needs to be accessible in line 7 when I go to initialize that person. Does that make sense, Andy?
Yeah, it makes sense. I completely forgot that super is within the def init. It makes sense.
Awesome. All right, Cody.
So when you create the veteran, are you creating an instance of veteran or an instance of person?
That's a great question. Let's go ahead and dive into that here. And we could just make a quick demonstrator. Gonna go ahead and, oh, I totally forgot that portion of the class yesterday. I apologize. I'll go into that today as well. I believe somebody asked me in regards to organization of how to handle different methods. I'll go into that today. I apologize, everybody. Let's go ahead and create a list of vets. And that is going to be equal to a list. And let's create a list of people. That is going to be equal to a list. Now here, I'm going to create a class method. My class method is simply going to append to the list. Let's just call it add to list of vets, which is going to take in CLS. And all it's going to do is say CLS dot append the new vet. So there's my simple method there. So now I'm going to call it and say self dot add to list of vets, pass and self. And we'll repeat that behavior over in the list of people. All right, here's all of my instance methods. And after my instance methods, I'll go ahead and declare my class method. Where my class method is add to list of people. Which again, this is CLS and new person. And all we're doing to do is CLS dot list of people dot append new person. And then we'll call it within our initializer here. So let's go ahead and do self dot add to list of people and pass in self. All right. Finally, I'm going to go ahead and print vet dot list of people. And then I'm going to print vet dot list of vets. Now, when I execute this, you're going to see two separate lists. And let me go ahead and specify here. This one's going to be people. And this one's going to be vets. Although I am calling the initializer method for the person, what's being saved in memory is an instance of a veteran. Right? You'll see that here we are saving the list of people. Down below, we are printing the list of vets. Although we are utilizing the initializer method from person, it is still being interpreted as a veteran object. That's what's being created and saved in memory. Does that answer your question, Cody? Perfect. Carlos?
So I don't know. If you would have printed out, it said where to say this, yeah, this 207 is sleeping. What happened there on in the terminal?
This 207 is sleeping. Where's it at?
That's like it's passing the height, or sorry, the weight into the name.
I actually don't know. Might have been a syntax error at some point. Let me go ahead and clear that. Oh, this 57 is sleeping. So there's an issue with this star name and so on that is happening here. It's creating some misbehavior within my code. So let me go ahead and fix that by just passing in, I believe it's name, height, weight, and then we said true. Good catch. I almost completely missed that. And there you go. All right, everyone. Let me go ahead and pause our recording here. All right, welcome back, everyone. Now, before we left, we finished speaking about all of the concept that is inheritance. We were able to create a dog class. From that dog class, we created a German Shepherd class, which inherited from dog. we saw that we had access to all the same methods, and we had access to the properties, excuse me, that were established within the class that was being inherited. In this example, we have person, which we built together. A person has name, height, weight, veteran, a couple of methods here, such as sleep, eat, and drink. On the left-hand side, oh, excuse me. Oh, that's correct. And then on the left-hand side, we created a veteran class, which has its own properties, in addition to the properties that are already being inherited, a little bit more unique to the veteran itself. We created an instance of said veteran, and we saw that in the background, when it's being created, what is being interpreted as, although we are inheriting from the person class, an object of veteran is what's being created under the hood. All right, now that we've got a little bit of practical application, before we continue speaking about polymorphism, does anyone have any questions over the topics that we covered up to this point? Great. Let's start talking about polymorphism. Let me take a step back here. Go back into our dog and our GSD. All right, so here we have our German Shepherd dog, which we saw we have all of the attributes, and we have our dog class. All the properties are shared. I don't need to import time here on the right-hand side anymore, or maybe I will here shortly if I want to utilize it. I'm just going to leave it for now. But now let's start talking about polymorphism. Polymorphism is in reference to methods having different actions. So for example, as of now, I have speak. When a dog speaks, all they do is return this self-sound with an exclamation mark. Now, German Shepherds in general are a bit louder. So maybe when I go to speak about my German Shepherd, I want to actually have my speak method be a little bit more proclaimed. If I call dog.speak as of now, you'll see that it returns woof with all capital letters. That's what I expected. I have woof in here, and you can see that the method of speak that is being inherited returns an exclamation point. Well, maybe I want there to be a different behavior for this speak, right? Well, if I want there to be a different behavior for speak, but the method is still speaking, all I will do is define speak. That takes in self, and then I would maybe overwrite the return statement there, where what I would do is say, hey, let's say, emphasized sound, and we can make that equal to self.sound.upper. And we can do is call emphasize sound a couple of times. All right. So now when I run my code and I say Python GSD, instead of just getting woof like we did the very first time when I had the speak method, well, now my speak method actually returns an interpolated string where woof is referenced to 3 times, and it's also completely capitalized. You'll see that even if I change this to be all lowercase letters, like woof, and then run it through, I still get the same output of woof, woof, woof. All right. This is a form of polymorphism. What I did is I analyzed a behavior. The behavior being a dog being able to speak. All dogs should be able to speak. Now, even though all dogs should be able to speak, a specific type of dog may take this behavior and do it in a different way. For example, a Chihuahua, I might put this woof, woof, woof sound hundreds of thousands of times, maybe put it on a repetitive loop, and then at the very end of it, put runs away if approached, right? Because we know that's what Chihuahuas do. They bark a bunch, and as soon as you get close to them, they run away. Well, the behavior or the actual execution of the behavior of speak may be different inside of my classes. So I utilize polymorphism to change the method depending on the class so that it matches the parent, right? All right. Does anyone have any questions over what we just did for polymorphism?
So it's just essentially overriding, or it's going to be looking in the GSD for that method first. If it doesn't find it on there, then it'll look over in the dog class.
It's essentially
Like,
overriding. I don't want to say that it's going to look over in the dog class. So everything that exists within the dog class exists here in the GSD class the moment we utilize inheritance,
Mhm.
right? What we're doing here is we're referencing the same exact method and we're redefining it. We're saying, hey, I know that there is something defined known as speak that exists within the dog class, but I don't want to utilize that method here. Instead, I want to redefine the behavior of speak so it can be accessed to by GSD.
okay. So just like reassigning a variable then.
Exactly.
Okay.
All right, Andy.
Um, I think I have the idea down, but if you would overwrite this and then delete it afterwards and run it again, would it still have that in there, or
So delete.
would it still go back to the original form of speak?
It would go back to the original form of speak.
All right.
All right. Any other questions? Okay, so let's go into chase tail. Let's rewrite this method of chasing the tail, where a German Shepherd is able to catch his tail within 3 seconds. How can I do that? And all right, I'll go ahead and call on people. Kino.
You want to use a timeout?
All right. How would I go into defining?
Oh, okay. I thought you was trying to maybe use the sleep method, but you want to define a function and basically using the def, and the name of the method is going to be timeout, um comma self, uh semicolon. And I guess the specific behavior would be using the sleep method. And you want, how long do you want to?
Within 3 seconds.
Yeah, 3 seconds. So sleep, and the parameter would be 3 seconds. It would just be three. Oh, I thought you want to use the method sleep. We could
Got
do
it.
that way, right?
Utilize time.sleep. Right.
Yeah. Or you just want to define a variable called sleep, however you want to do it.
All right, awesome. Now, is this actually utilizing polymorphism?
It's utilizing polymorphism. I'm not quite sure because I mean, depends on if the behavior can be changed. I mean, if you pass a parameter, maybe for timeout, then you could change the behavior for each specific animal, maybe like maybe the Chihuahua can only sleep for like 5 seconds, and maybe the what's the other dog can sleep for 5 seconds. Would
Okay.
that kind of work?
Yeah, I don't think the issue is the actual sleeping portion. This should
Yeah,
be utilizing polymorphism because it's not overriding something from the parent class.
right.
So let me go ahead and pass it on to Cody here because I saw his hand go up. Go ahead, Cody.
I was just gonna say that it needs to match the chase tail method.
All right, so let's do that portion there. So let's say this is going to be chase tail. All right, now it's utilizing polymorphism, right? Because we are redefining the chase tail from the parent class of dog. Okay, great. And now we could just go ahead and build out our method here. Let's say hot tail or let's just say we have a counter be equal to 3. Say while counter is greater than or equal to 0. Actually, greater than 0. Then let's say print. Oh, hello. And now we could actually utilize an F string and say self.name is chasing their tail. Then counter minus equals 1. And then finally we could print, or excuse me, return an F string that says self.name dot their tail. Now, if I go to execute my Python GSD here, and I go into the catching method, so I say print my dog dot chase tail, I execute it, we can see Apollo is chasing their tail. We get that 3 times, and then we get Apollo caught their tail. Whereas if I comment out this redefinement, and I then execute my code, we can see dog is now chasing tail. So that was the original method from the dog class that we have now redefined to be unique to a German Shepherd dog. All right, Carlos?
Well, it was just going to be so really, if technically, if you weren't going to like, I guess, personalize it and do self.name, really the only thing you would have to do is copy and paste the code that's under the parent class and then just change the 5 to a 3, right? That would be the same thing.
That would have done the same thing, yes.
Is there a well, no, because once you do the polymorphism, like it completely overrides the previous one. Because I was gonna say like a way of referencing the old behavior, and then just updating that one variable there. And so instead of a 5 being a 3.
You wouldn't be able to reference the
Yeah.
counter or something like that. You could reference the old chase tail. So like what you can do is maybe passing a time, right? Or something like that as an argument.
Okay.
And then what you can do is you could call it within here and say, hey, in dog chase tail, pass in an argument. Right? And then
Okay.
that will isolate it to the dog, not to the GSD.
Gotcha. Thanks.
Of course. All right. Any other questions? Awesome. So now we see 2 examples of polymorphism. We understand polymorphism a bit, but let's start continuing down this path of inheritance. So far in this people, we have been able to create a person, and we also have the ability to create a veteran. But let's say I want to create a 3rd class that utilizes something called multiple inheritance. So now in this 3rd class, I'm going to create a parent. All right, now this parent is going to be both a person and a veteran. This parent is a person and a veteran. And let's just go ahead and put in number of children for now. As their own unique property there. Now, If I were to utilize something like multiple inheritance, well, one, I know that I'm going to need both of these classes. So I'm going to say from person, or I can just grab them from the veteran file, import veteran and person. So now I have access to both of those classes. This may raise the question, well, why is person available in the veteran file? I didn't create it there. I made it in the person file. Yes, but I do import person on line 1 inside of my veteran file, meaning that both person and veteran exist within the file named veteran.py. So I can import both of them. Let's go ahead and make sure both of those import statements worked. All right. So we can see that both of those import statements work. I see a print statement at the bottom. That's because the code down here is still being executed. So I'm just going to go ahead and comment this out. Perfect. So that's my, I can see that both veteran and person were imported. Now let's go ahead and create our class. Now, when I go into creating this class, I can do it as such. I can say, hey, well, now I have a person that is both or I have a new, you know what, this is not a good example of double inheritance.
Why not? Because a veteran is a subclass of person, and you want two completely separate classes.
Exactly. So as of right now, what we're doing is we have veteran, we have person, but ideally, double inheritance would be something that's like, let's stick with the parent concept here. But a parent would be a veteran, or even better. That's what we'll do. All right, we could have a parent, and then this could either be a mother or a father. There you go. So let's go ahead and quickly define our parent class. So let's say a class of parent, which may also be a person. We'll pass our init method here. Now for a init method, we know we're going to need everything in regards to person. So I can just go ahead and grab all of those attributes there. Bring them over. And then start working through this. So now I have a veteran, or excuse me, I have my parent there. I'm going to pass. And let's say number of children was what we wanted to see there. And now we can call our super method to initialize. We have name, height, weight. We can still call the veteran portion, or do we just pass this in as false in this case? And let's say that the number of children is 3. Oh, excuse me. That doesn't go there. All right. Now, if I go to create an instance of the parent class, I could say, hey, new parent is equal to a parent that takes in a name, . height, weight, and then number of children. So let me go ahead and print new parent dot name. And there we can see Francisco. If I go and print just the new parent, we'll see that what we have is a parent object showing up. Great. Well, let's change this up a little bit. Now we're going to utilize multiple inheritance to define a mother or a father. A veteran is a person, just like we saw there. This isn't a requirement. A parent is also a person. I'm not repeating myself. But now, I may take this a step further and actually create something that requires multiple inheritance. Let's say I have my class of father. Well, a father, and I apologize that I missed something. Wait, veteran, person. Okay, cool. So now a father may be, or may be a parent, and also may be a veteran. Now both of these could be initialized as such. Instead of utilizing the super method, I want both of them to be initialized separately. So I can say, hey, I want parent to exist. So I'm going to take in all of these. And then I'm also going to take a look at veteran and grab any uniques that belong to the veteran, such as awards, branch, and NJPs. All right. Now, when I go to initialize this, I can simply say parent dot init passing self, passing the name, the height, passing in the weight, and then pass in the number of children. And then I can say parent, or excuse me, I can say veteran dot init, where I can pass in self, same thing as before, name, height, weight. I don't need the number of children. Instead, what I need is awards, the branch, time in service, and NJPs. All right. Now let's go ahead and create our parent class here. I'm going to say new parent, or let's just call this Francisco. Gonna pass a bit of a dictionary there. I'm going to say name will be Francisco. The height will be 5'7". The weight will be 207. Number of children, in this case, will be 1. Awards, not enough. We have branch for branch of service, which in this case we have USMC. TIS. and then NJPs. Which let's build two. All right, so there's all of the arguments that are being passed into both of those independent classes. Well, let's take a look at Francisco. All right. False, missing two position arguments. Branch. Where is that happening? All right. Ran into a little bit of an error. Let me figure this one out. Okay, the most recent recall happens in line 19. Okay, and that says parent.py line 12.
Yeah, because your dictionary doesn't have time and service.
Yeah, yes, this.
Yeah, but you
It's
you're supposed to
missing
be parent,
veteran.
right?
Give me a second. Give me a second.
Oh, what you initialized was the parent instead of veteran, I think.
All right, let me think this one through. Let me see. So users line 12. Init, name, height, weight, false, veteran.init. Okay, so that's happening at the veteran side. Missing three positional arguments. Nope, it has those arguments. Branch TIS. Do some sort of syntax error here.
Yeah, like I said, you initialize father or the parent instead of veteran. But you're supposed to be able to.
What are you asking? I think you're confusing
No,
me.
you initialize the father.
Yes.
It's the veteran. It's I think what is looking at is yeah, it's thinking you're trying to initialize veteran. So
All right, let me see. Let's give it a second here. So currently right now it is 11:29. Go ahead and let's give me 6 minutes to figure this little error out, and let's come back at 11:35 to continue. Thank you so much, everyone. All right, welcome back, everyone. So it seems like what got this class working is us being able to switch veteran and parent. I have to look into why that switch is necessary. The one thing that I could think off the top of my head would be the fact that veteran is established prior to the creation of parent. But I have to look into it and see how exactly this MRO thing that has been mentioned by you guys works and what's going on behind the scenes regarding this multiple inheritance. Now, let me go ahead and dive into this Francisco object. As of now, if we print Francisco object and take a look at their veteran status, which we know should either be true or false, we define that here inside of the person. If I go into execute this block of code now, you'll see that it comes back as false. If I were to switch these two, oh, and it still comes back as false. Why is that? All right, seems to be coming back as false for both of them. So even though we're establishing, hey, the veteran is actually, excuse me, here, a veteran, we're saying that whenever they're created, it's going to equals true. This has to do with that MRO portion that we're talking about. When I go into my file of parent, too many files open. When I go into my file of parent and I execute the order, or I view the order in which information is being interpreted in the background, you can see that the class of veteran would get executed first, which would turn our variable of veteran to true. And then the class of parent gets executed second. So it grabs that variable and turns it back into being false. Right? Again, I have to figure out why this switch needs to happen and get back to everybody. But now we can see that I have both attributes here inside of this Francisco object. If I go into this Francisco object, I can see that I can access something like awards. All right, so awards is present. And I can still access my number of children. And I execute it, and I get back, ooh. Why is number of children returning true? Parent, number of children. Interesting.
Is this the same issue where it's 1 star versus 2 stars on your dictionary?
No, I don't think I said it's because it's interpreted number of children, one is just true. But it's not interpreted as an integer. It's interpreted as a Boolean.
I don't think that's the case. I think
No,
Or
it looks like it's picking up the veteran status and putting it to true. What would
oh,
happen if
Could it be
inside
that it's 1
the
and 0 and
dictionary?
you're not typecasting it to an integer?
Self, name, height, weight, number of
Oh,
children
no, because you got 2. Never mind.
into the parent.
this is definitely undefined behavior.
What would happen if in
If
your
you did number of
dictionary of all the
children,
values you're submitting to the functions, you included the veteran status instead of assuming that it's going to be true based on the code earlier?
Oh, I see. Oh, I get it. I see now. Okay. Yeah. It's positional arguments, right? So the keyword arguments. Right.
Yeah,
All right,
it's
everybody.
for some reason
So
thinking the
here's
thing in place of that
we're
is
starting to lose track of the class, and this is definitely my fault for not being able to show you guys a good and effective example of this multiple inheritance portion. So we'll come back this afternoon and we'll dive into multiple inheritance again. We'll re-prepare this portion, and then this evening we'll go ahead and dive into this multiple inheritance to demonstrate it once again. And I apologize here.
No, this is interesting though. I mean, it's a learning experience, right?
yeah,
It's
because
all
I'm probably gonna make these exact same mistakes if I hadn't seen it before, and
yeah,
I'm gonna be confused. And now at least I know, hey, this is a thing. I need to be careful.
Go ahead, Cody.
definitely learning.
I was gonna say in your parents and veteran, you could make it strict by doing key value pairs like name equals name. So it's not it doesn't go based off of order anymore. You're basically declaring like telling it what this is.
Yeah, and
That could clear up that order of variables issue.
yeah, that should work, but unfortunately, it's also giving me a bit of an error in the background. So let me go ahead and dive into this portion of this father and or excuse me, of this parent and stick to the parent class here. All right, so we know that the parent class works. We're gonna stick to the parent class for now, and then we'll dive back into this portion of speaking about multiple inheritance later on. Now, the last pillar of OOP that we haven't covered, we've gone over encapsulation, abstraction, we've covered inheritance and polymorphism. The last thing that we have to talk about is something called composition, which is a has a relationship, right? So a parent is a person. We'll wait for that veteran portion. But we also have to specify that it has a child. So the simple thing to do here is we can do class child. This is also a person. We would define our initializer, pass in self, pretty much everything that goes into a person there. And then afterwards, maybe we can specify something like, what else could go into a child? We have name, height, weight. Let's do something.
Favorite toy.
Say again?
Favorite toy.
Age and favorite toy. Why not? All right. Now for age, we can say, well, first, let me go ahead and utilize the super method to initialize my person class. Here we'll pass in name, height. We can pass in their weight. And then we'll pass in false. Then we can do self.age is equal to age. And we can do self.favorite toy is equal to favorite toy. Now, when we start talking about this children, we can, instead of specify number of children, we can say first born. And this firstborn we can still say, hey, this is going to be a firstborn. But when we pass here in the arguments, we can specify, hey, we are going to take in a firstborn, but this firstborn should be a child. Now, this is not inheritance, right? This is has a child. And parent is a person. So when we go to create a child, so let's say child, we know they're going to need a name, which in this case, let's go with Michael. We know they're going to need a height, which in this case, let's go ahead. Let's just go with 2 feet. Why not? Let's go with weight. Say 27 pounds. For age, we'll go ahead and specify that they are 3. And let's say favorite toy. And specify that the favorite toy is Pikachu. All right, I see a hand go up. Go ahead, Carlos.
Is there a reason that you put the height as a string and the weight as an integer?
Just for something like this, child 8, so
Okay.
8 inches, no specific reason. All right, so now I could say child object, which is equal to a child that is created. We're going to take apart that dictionary. All right, so let's make sure that this executes properly. All right, I see no errors. So that's executing up to this point. Now let's go ahead and build a parent. So new parent or parent is equal to where the name, in this case, we have Francisco. We have the height, which is going to be 5'7". We have the weight, 207. What else falls into the parent? Number of children, which we don't use anymore, so we don't need that portion. The last portion is going to be firstborn. So now, for firstborn, I can specify my child object. And I can say parent object is equal to parent of parent. Now let's go ahead and print parent object dot name. We'll see that that works correctly. And we can go into parent object firstborn and grab the name of the firstborn. And that will return Michael. Right? Because my firstborn is an instance of the class of child. All right, again, that is a has a relationship, not an is a relationship. Has a is known as composition. Is a is inheritance. All right, does anyone have any questions about the difference between composition and inheritance? All right, let's hear it, Carlos.
So is that kind of since you're specifying, well, not necessarily specifying, but you're saying, firstborn is of class child. Is it technically a has a whatever, or like has a relationship kind of thing? With like if you were to do weight as an integer. I don't know if that makes sense.
So you're saying do weight as an integer, but are you saying is weight
Because
composition?
never mind. No, I don't know if I can put it into words.
So what
You're
I'm
talking about
here,
typecasting?
Yeah.
so typecasting is not a form of composition. So what I'm referencing to here is the fact where an object will hold another object within it. So this here is inheritance, right? My person, or excuse me, my parent is a person. So the concept of the entire person falls between it. But inside of my parent, I may also have attributes, or excuse me, properties, which we've seen, such as name, and what else do we have here? Height, right? Now, if I were to create, and let me color code this as well. So outside we have our classes, and inside we have our properties, right? Well, what we did is we just created an entire other class. This other class is of child. Child is also a person, but a parent has a child. So the key difference between name and height is that name and height are properties that belong to parent that would hold a value that doesn't relate to another class. So the reason why this is composition is because one of its properties is of a class that we have also created. Did that answer your question, Carlos?
Okay. Yeah, it does. Thank you.
Perfect. Cody?
Could you go back to the code?
Absolutely.
I'm not connecting the dots. So with so you have your child object and then you go down to the parent where you go down to where your print statement is. So firstborn, how does it like say you have more than one child instance? How's it no? It doesn't seem like you're specifying the instance you created on the child. It's just like say you have more than one child instance created. Because I don't see like if you scroll up, I don't see where you're selecting child object to specify that specific instance
Got it. So that's
to
happening.
get that name. Oh,
Yeah.
there it is. You're right. There it is. I didn't see that part.
Yeah, that's
Okay.
here on line 40.
Okay. That's all.
Awesome. Any other questions? All right. Awesome. If there aren't any other questions, we will review multiple inheritance here shortly. But before we're actually at time, So we'll do a demo of pair programming later on this evening as well. So there's two things to cover. We'll do pair programming and we will cover multiple inheritance this evening. I apologize to everyone about that multiple inheritance incident. But up to this point, what we did cover now is the 4 pillars of OOP. And today we focused on the concept of inheritance and polymorphism. Does anyone have any questions over the topics that we covered today, with the exception of multiple inheritance? Perfect. Let me go ahead and stop our recording here.